radical form and rational exponent form. So the idea of these is the denominator of your fractional exponent is the same thing as the root number. And then the number up here is the same thing as your numerator number. I'll show you a couple examples. So if we had something like the cube root of x squared, that would be the same thing as x to the 2/3. So the 2 went on top, and then the 3 from the root goes on the bottom. And if it helps, you can think of root as like the roots of a tree. So if we have a nice little tree, I don't know how to draw a tree, but it's got roots. Well, the roots are in bottom. So this root in the bottom of your fraction is the root of your rational expression. So another example, x to the 3/4. Well, this 4 is like the roots of your tree, the roots of your fraction. It's on bottom. That's going to be the root, the 4th root. And then this x cubed is like this. These notes don't include it, but you also could write it as the 4th root of x cubed. I'll probably update those notes at some point. These mean the same thing. You can rewrite it either way. So hopefully this makes sense. The root, the number on bottom, is the bottom of your fraction, or vice versa. And then the thing on top is the top of your fractional exponent. We can try one here. It says express in rational exponent form, the cube root of x squared. So rational exponent form means a variable and then a fraction. So what's going to go in our fraction? Well, first off, the variable is x because this is x. If this was a y, this would be y here. That needs to match. Now, on my fraction in my exponent, the 3 is the root, so it's going to be the root of my fraction, or the denominator of my fraction. And then this 2, which is already up high, is going to be up high in my fraction. So the answer to this should be x to the 2/3. And it is x to the 2/3. We can do another one of these, the 5th root of 2 cubed. So if we want to write this in rational exponent form, it would be a 2 to some fraction. And then this 5 goes on bottom because the root goes on bottom, and this 3 will go on top. So 2 to the 3/5 should be the answer to this one, and we can check it. And there it is, 2 to the 3/5. So let's do one more. The 4th root of 3.1 to the 7. So this time our base is going to be 3.1. Then we have a fractional exponent again, because that's what rational exponent form is. This 4 is going to go on bottom, because the root goes on the bottom of your fraction, and the 7 is going to go on top. So the answer to this should be 3.1 to the 7/4. And we can check it, and we get the same answer, 3.1 to the 7/4. So that's how to express in rational exponent form. Next, we're going to go the other direction. Now we're going to express in radical form. So this is the form, and we're going to fill this in. The z is our base. The 7, the root of the fraction is the root of the radical, or the denominator of the fraction is the root of the radical. This 7 is going to go here. And then the 1 goes there, and we don't even really need to include a 1. So this is just the 7th root of z would be the answer here. And we can see that that's the answer. So we got that one right. Let's try another one. So same thing, express this one right here in radical form. So if we're going to do radical form, it's going to have a radical. And this first 5 is our base. This 5 is the exponent for the base. And this 2, the bottom of our fraction, is our root. That's it written in radical form. 2 there isn't necessary because square root is an implied 2. We don't need to include the 2. These are the same thing. So I'm just going to put the answer like this. Let's see what the answer is. They did not include the little 2 there, square root of 5 to the 5. And that could be simplified, but all this asked for was to express it in radical form. So we're done at this step. We don't have to actually simplify it. Some teachers may ask you to simplify it, or you may be implied you're supposed to simplify it. You can do that if you want, but as far as this problem is, I'm just going to stop there. Let's do one more. So for the last one, we'll do this one on bottom here. So same thing, radical form means it's going to be a radical. We're going to have the 4.2 here. This 4 in the denominator is our root, and this 3 is going to go there. We also could write this, if we wanted to, as the 4th root of 4.2, the whole thing cubed. Both of these are valid. I'm pretty sure the answer here, when we hit show answer, is going to show us this one, but either of these would be right. And there it is, the 4th root of 4.2 cubed. So that's it for radical form and rational exponent form. All these problems came from a page on andymath.com. I'll include a link down below in the description if you want to try it yourself. Here's the page right here with all the problems that we just did. And then there's related pages too. So if you want to do more exponent stuff, please like this video and subscribe to my channel. It really helps. And I'll talk to you guys soon. Bye.